Good morning. I am Dr.A.Rathinavelu, Assistant Professor in Chemistry, Department of Chemistry. Today we will discuss about aromaticity and what are the aromaticity, definition for aromaticity, what are the conditions for aromaticity, what are the criteria for aromaticity, and what are the classifications of aromatic compounds, anti-aromatic compounds and non-aromatic compounds, what are the conditions for aliphatic compounds, what are heterocyclic compounds, what are benzenide compounds and non-benzenide compounds, what are fullenes, what are the classifications of fullenes, what are full valence, what are the classifications of full valence. Now we discuss about definition for aromaticity. The aromaticity was discovered in 18th century. The word aromaticity is derived from aroma. The aroma is a pleasant fruity odor. It has a benzene like structures. The aromaticity classification is aromatic compounds and non-aromatic compounds and anti-aromatic compounds. The aromatic compounds like that benzene and benzenide structures. Examples benzene, naphthalene, anthracene and phenanthracenes. Non-benzenide compounds other like that aliphatic compounds for alkane, alkene and alkynes, etc. Next we will discuss about the criteria for aromaticity. The molecules must be acted with the aromatic characters. It contains with the cyclic, planar, conjugations and presence with the hybridized b orbitals. The must be obeyed with the Huckel rules. Huckel rules means 4n plus 2 pi electron rules. Okay, conditions for aromaticity. The aromaticity, the molecules acted as the aromaticity, it must be obeyed with the following conditions: cyclic, planar, conjugations, presence with the unhybridized b orbitals and delocalizations, and must be obeyed with the Huckel rules. The Huckel rules means 4n plus 2 pi electron rules. The aromatic compounds can be classified with benzenide and non-benzenide compounds. The benzenide compounds is a homocyclic benzenide compounds and heterocyclic benzenide compounds. The homocyclic benzenide compounds means the compound must be contained with only one benzene ring. The heterocyclic benzenide compounds like that the compounds must be present with a carbon atom replaced by any one of the heteroatoms like that nitrogen, oxygen, sulfur and then phosphorus. Another one of the case like that benzene. Benzene is a good examples for benzenide compounds. It contains with 6 pi electrons. The non-aromatic compounds like that cyclobutadienes contains with 4 pi electrons. The anti-aromatic compounds must be cyclic, planar. It contains with a delocalization of pi electrons, 6 pi electrons, 10 pi electrons, 8 pi electrons and 12 pi electrons. The fullerene, all types of fullerene compounds can be acted with non-aromatic nature. Suppose the fullerene compound attached with any types of substituents, it can be present with aromatic natures. The full valene contains two types of compounds, the ring A and the ring B. Both the ring must be present with the same size. It will be acted with the aromatic character. Suppose the ring A is 5 members, ring B is 3 member, it will be acted with the non-aromatic compounds. அதுக்கடுத்து வந்து பார்த்தீங்கன்னா nucleophiles and then electrophiles. The nucleophiles means nucleus loving species. Electrophile means electron loving species. And nucleophiles negatively charged species. Electrophile positively charged species. The nucleophile can be attacking with the electron deficient sites. The electrophile can be attacking with the electron rich sites. Okay, what are aromatic electrophilic substitutions? The electrophile can be attacking with the aromatic compounds. The original aromatic compound can be disturbed to get a new substituted product. These types of aromatic substitution is known as aromatic electrophilic substitution reactions. The aromatic electrophilic substitution reactions can be classified the number of cases. One is Friedel-Crafts alkylation, acylations and halogenations, sulfonations, nitrations. The number of aromatic electrophilic substitution reactions will be present. So what are Friedel-Crafts alkylation? The alkyl group can be introduced into the benzene ring. Friedel-Crafts acylations means the acyl group introduced into the benzene rings. Halogenation means the halogen families like that chlorine, bromine, iodine can be attached in the benzene rings in presence of Lewis acids. The nitration reactions of benzene means the Benzene can be treated with the concentrated nitric acids and concentrated sulfuric acids in presence of Lewis acid to get a nitrobenzene. The product will be appear with a yellow color. Another one of the case like that, sulfonations. The sulfonation means the sulfonic group SO3H group can be introduced into the benzene and substituted benzene ring. This types of reaction is known as sulfonation reactions. Now we discuss about aromatic electrophilic substitution reactions. The electrophile can be attacking in the benzene ring. This is known as aromatic electrophilic substitution reactions. The aromatic electrophilic substitution reactions generally contains with a three-step mechanism. The first step is a generation of electrophiles. The second step is a formation of sigma complex. The third step is a removal of protons. How does generated the electrophile? The electrophile can be generated with the spontaneous dissociations. This electrophile can be attacking with a benzene ring. First form with a bicomplex. This bicomplex will be unstable. This unstable complex will be omitted again to get the sigma complex. The sigma complex can be attached with the electrophile to get a substituted compounds. Aromatic electrophilic substituted products like that halogens like that chlorine, bromine, iodine. Suppose nitronium ion will be attached, this is a nitro group, and the sulfonic acids will be attached, this is a sulfonations. Suppose the failure of this mechanism, the halogenation, sulfonation, nitrations, it will be moved with a Priddle-Crafts alkylation and acylations. Already we know that the alkylation means the alkyl groups like that methyl group, ethyl group, propyl group can be attached with a benzene ring. This is known as Priddle-Crafts alkylation reactions. Acylation means the alkyl group can be replaced in presence of added with the acyl group. Acyl group means CH3COCl group. The acyl group come from acetyl chlorides like that benzyl chlorides to get the acetophenones and the benzophenones. The acetophenone and the benzophenone can be reduced to get a alkyl benzene or aryl benzenes. Next we will discuss about the Golp reactions. According to the top Golp reactions, in these reactions, sodium phenoxide ion directly passing through the carbon dioxide at a low temperature to get orthohydroxy benzoic acid. Suppose temperature will be replaced by introducing to get a parahydroxy benzoic acids. The next one is Riemann-Tiemann reactions. The Riemann-Tiemann reactions like that production of benzaldehydes. The phenol is treated with the chloroform in presence of sodium hydroxides to get a benzaldehydes. This types of reaction is known as Riemann-Tiemann reaction. Suppose a catalyst replaced by chloroform can be added with carbon tetrachloride to get a acid, the orthohydroxy benzoic acid, that is like that salicylic acids. Riemann-Tiemann reactions. According to these reactions, this reaction mainly used for preparing benzaldehydes. Benzene is treated with the chloroform in presence of sodium hydroxides to get a benzaldehydes. Suppose the catalyst chloroform can be replaced by using carbon tetrachloride to get a orthohydroxy benzoic acid. This is similar to the top aromatic electrophilic substitution reactions. The three-step mechanism, formation of sigma complex and removal of protons and formation of electrophiles. Okay, thank you.